We also have something called dependent events. So dependent, if you think of what that word means, you're relying on someone else or relying on something else. And so this is where the occurrence of one event does affect the likelihood of the next event occurring. So some examples of this would be like having a bag of marbles, pulling a marble out, and not putting it back in before the next draw. And so this could be, it could be a collection of marbles or any kind of collection or bag of something, but you're not going to put the item back in the bag before you draw the next one. So essentially that second event's probability has changed depending on whatever happens first. Another example of this would be pulling two items out at the same time. Two or more items out at the same time. So if we think of those 10 cards, numbered 1 through 10 again. All right, there's my 10 cards. Find the probability that you draw 2, keep it, and then draw a 5. So we have this key phrase. It tells us I'm taking that 2, but then I'm going to keep it. And so then I'm going to draw a 5 after that. So again, I want to know my probability that I'm going to draw 2, and then the probability that I would get a 5 after the 2. So right now, if I look, my probability of drawing a 2 is 1 out of 10. And then we're going to pretend like I drew the 2. So now it's gone. And so I want to know the probability that I draw a 5. Well, I have 1 5. But now I only have, 1 5. But now I only have 9 cards. And so I'm going to multiply those probabilities. And so 1 times 1 is 1, 10 times 9 is 90. So I have a 1 in 90 chance of pulling a 2, keeping it, and then drawing that 5. So now we're going to reset my 10 cards. So I still have those 10 cards numbered 1 through 10. It says without replacement. So this is another way, another indicator that we're going to be talking about dependent events. So we're not going to be replacing the first item. So without replacement, you draw 2 cards, find the probability that you draw 4, and then an even number. So right now, the probability that I would draw 4 would be 1 out of 10. Okay, again, our collection has been kind of reset for this second problem. And then we're going to imagine that, okay, I pulled the 4, and it says without replacement. So I have the 4, and I'm not replacing it. So now I want to know the probability that I would get an even number. So again, we're actually down to 9 cards now. So our total possible outcomes has changed. And if I look at my number of even cards that I would have left, I'd have a 2, a 6, an 8, and a 10. So I'd have a 4 out of 9 chance there. Okay, and we're going to multiply. So I'll get 4/90ths. That fraction can be simplified, and I know that because 4 and 90 are both even numbers. So I can divide these both by 2 and get 2/45. So I have a 2 out of 45 chance of drawing a 4, keeping it or without replacing it, and then getting an even number after that. All right, we're going to look at a couple of other examples, and we'll talk about how to classify these as either independent or dependent events as well. So number 1, you flip a coin and roll a number cube. What's the probability that you flip tails and roll a number less than 5? So first of all, if I just wanted to know if this was independent or dependent, we're going to look at what's happening here. So I'm flipping a coin and I'm rolling a number cube. My coin flip is not going to affect what that number cube is going to roll, and so these are independent events. So I want to know the probability that I'm going to get tails and a number less than 5. So the probability that I would flip tails on the coin is 1/2. And then on my number cube, a number less than 5, I would have four favorable outcomes out of the 6 possible outcomes. And so my probability of that happening is 4/6. And then I can multiply. You could either multiply straight across here, or I noticed that 4/6 actually simplifies to 2/3. So I'm going to go ahead and simplify that before I multiply. And then now I also know that when I look here, I can do some simplifying within the problem. So my numerator of 2 here and my denominator of 2 here can both be simplified by 2. So that's going to become a 1. This will become a 1. And so now when I multiply straight across, 1 times 1 is 1. 1 times 3 is 3. So I would have a 1/3 probability of flipping tails and rolling a number less than 5. If the simplifying within the problems didn't make sense, you should still be able to get your fraction simplified to 1/3. Number 2, you have a bag of marbles with 3 purple marbles and 1 yellow marble. Find the probability of drawing a purple marble, putting it aside, and drawing another purple marble. So when I read this, I want to first decide, is this independent or dependent? And so when I see the words putting it aside, that's going to tell me that this is dependent. So I want to know the probability of drawing purple. And then the probability that I get another purple. So my first chances of getting purple out of this collection of marbles over here would be 3/4. Now this says that I'm drawing it and I'm putting it aside. So let's pretend that I have the purple marble, I'm putting it off to the side. Now I need to look at what my chances of drawing another purple marble are. So this purple is no longer here, so I actually have 2 out of 3 chance, a 2/3 chance now. So I'm going to be multiplying these. Again, I see some simplifying that I can do within my problem. So I see my 3's can both be simplified. Okay, I can divide both of those by 3 and get 1. And then I also see the 2 and the 4 are both even numbers. And so I can divide those both by 2. And when I multiply straight across, I'm going to get 1/2. So I have a 1/2 chance of the drawing a purple, keeping it, or putting it aside, and then drawing a purple again. We're going to look at this one now. A game has a deck of cards with 12 red cards, 5 blue cards, and 3 green cards. You win if you randomly choose 2 blue cards without replacement. Find the probability of winning. Decide if it's independent or dependent first. So this says without replacement, which tells me this is going to be dependent. And so I want to know the probability of choosing blue and then blue again without the replacement. So this one I'm going to have to first add up all of my cards to figure out my total. So I have 12 reds, 5 blues, and 3 greens. So altogether I have 20 possible outcomes. And so my chances of randomly drawing a blue card for that first one are 5/20. So I have a 5 out of 20 chance there. And then since I'm not replacing it, I have to think of how many cards I'm going to have back. So now I have only 19 cards, okay? But my number of blue cards has also changed. I no longer have 5 cards. We're going to assume that I have that first card as a blue. So now I really only have 4 blue cards left. So I have a 4 out of 19 chance for the second event. And then we're going to multiply this. Again, usually dealing with fractions, it's easier if we simplify them. So I know 5/20 can simplify to 1/4. So I'm going to rewrite that as 1/4. And then now I also see that I could simplify my numerator and my denominator by 4. So that's going to simplify to 1. This simplifies to 1. So multiplying straight across, 1 times 1 is 1. 1 times 19 is 19. So I have a 1 out of 19 chance. All right, and a spicy problem. We have 8 pairs of socks in the dryer, 1 pair is blue, and the rest are white. Find the probability of randomly choosing 2 blue socks. So if I have 8 pairs, that means I have 16 socks. So first of all, my probability that the first sock is blue is going to be 2/16. So now if I'm randomly choosing 2, I guess this should say at the same time, then once that first sock is blue, or assuming the first sock is blue, now I'm down to 15 socks and only one of them would be blue. So again, we can do some simplifying here. 2/16 simplifies to 1/8, so 1/8 times 1/15. And when I multiply straight across, I'm going to get a 1 out of 120 chance of those two events happening. Have a great day.